So in this video, I'm going to show you how to find the binomial expansion of 1 over 1 minus x up to and including x to the fourth term. So first things first, you need to rewrite this f of x in terms of a non-rational expression. So then we've got f of x is also equivalent to 1 minus x to the power of minus 1. So that will be the same as that. Next, what I need is to show you guys the binomial expansion formula. So what that gives us is 1 plus ax to the n. That's equivalent to 1 plus n ax over 1 factorial, and that's the power of 1. Next term is n minus 1 to the ax squared over 2 factorial. Next one, n minus 1, n minus 2 ax cubed over 3 factorial. And now you can see there's a pattern forming on how we calculate all of these terms. n minus 1, n minus 2, n minus 3, ax to the 4 over 4 factorial. Let's just write that 4 a little bit nicer. Okay, so now what we need to do is to work out our building blocks to plug into this. So we've got 1 plus ax to the n. Now here we've got 1 minus x to the minus 1. So our n value, that's minus 1. And our ax is just minus 1x. So ax is minus x. So wherever you see an ax, plug in minus x, and wherever you see an n, plug in minus 1. Okay, so now let's go into this. So this is now equivalent to 1 plus, that's just a constant, n is minus 1, and then minus x. And that's all over 1. So that's the first term. Second term, minus 1, minus 2, and then we've got minus x squared, that's over 2. So that would take care of that one. Next one, plus minus 1, minus 2, minus 3, and then minus x cubed, and then that's over 6. Next one, so now we've got minus 1, minus 2, minus 3, minus 4. This will be over 4 factorial, which is 24. And then ax to the 4 minus x to the power of 4. Okay, now let's just simplify this off. So then that's equivalent to 1 plus minus 1 times minus x is plus x over 1. It's just x. Now we've got minus 1 times minus 2 is plus 2. Divided by 2, that just gives me 1. And then minus x times minus x is just plus x squared. So then I've got x squared. Then here I've got minus 1 times minus 2 is plus 2. Times minus 3 is minus 6. Over 6 is minus 1. And then minus x cubed is minus x cubed. Times minus 1 gives me plus. So I've got plus x cubed. And then here I've got minus 1 times minus 2 is 2, times minus 3 is minus 6, times minus 4 is plus 24, divided by 24 is just 1, and then minus x to the 4 is just plus x to the 4. So that's my term up to including x to the 4. So I'm just going to put some dots there. So then I've got my f of x is equivalent to that, keep going on and on. And we also need to know where this expansion is valid. So for the expansion to be valid, what we need is to find our ax term, put it in a absolute value or modulus, and set that less than 1. In our case, ax is minus x. So then we've got minus x is less than 1. So in this case, modulus of minus x is just x. So then we've got x is less than 1. Now another way we could express this expression here is, in this case, 1 over 1 minus x That's the same in doing sigma notation. So n equals 0 to infinity of just x to the power of n. And that's ways of writing this expression as well in terms of sigma notation. So this is the answer to our question that we answered at the beginning. This is where the series is valid, and this is the series in terms of sigma notation. Okay.